Shall we start?
Yep.
During lunch, I felt it was too cold outside. I was telling the guys to make it warm. Hopefully, I think it'll come up, the temperature.
If you have machine learning for that.
Absolutely. Actually, there's a story about Google, actually, data centers, they've actually managed to reduce the power consumption based on ML stuff. Yeah. The point I'm trying to make is the unusual cold in the room is not to make it inconvenient for you guys too. We want you to stay in the room. Yeah, that's why. Was it? Yeah. Was it okay? Okay. Yeah, I was feeling I think it was a little colder here too, but anyway, so thank you very much for coming. Guys who have come back from the morning session, I think thank you very much for coming. And people have joined just for this 1 hour session. I think I'll talk about ML frameworks. Machine learning is a difficult topic to actually explain. And the most difficult topic is to actually talk about which framework is better. And I don't know how many of you guys are working for those specific companies, let's say Amazon, Microsoft, Google, Facebook, any of these companies. I will be stepping on your toes, I think, for a minute. So if you're recording, please don't record. I'm the one recording here right now, my speech. But if you're recording, please let me know. I'll be a little more careful about what I'm going to say about those frameworks. This again are purely my opinions based on what I've been speaking with a bunch of people and my own practical experience of working on these models and frameworks. And of course, some of the frameworks are constantly evolving. Maybe I think
by saying as of now.
As of now, yeah. So in a month from now or 2 months from now, if I give the same speech, I have to go back and modify the slides. I just can't reuse the same. That's what is happening. My name is SK, and I'll try to talk about a few highlights of each of the frameworks which seem to be doing well. And then towards the end, I will talk about my personal preferences of the frameworks, what I would use in certain scenarios. And of course, I would recommend the same thing for you guys too. But again, there may be difference of opinions, and I'll be more than happy to talk about those opinions. There are so many frameworks, and open sourced, paid. Some are trying to even help you do automated ML, where you can just develop a machine learning solution or a model for you, including even all the combinations of hyperparameters. It'll actually do it for you. So there's so many models available, and I think one of the latest one, I think I have come to know, is one by Baidu. It's called Paddle. Actually, it's if you go to the website, it actually says paddlepaddle.com. So I don't know the name of the framework is Paddle or Paddle. So, but there's so many frameworks, and even though I feel machine learning is so latest and so recent, there is already one framework which is doing a sunsetting. I don't know if you already heard of that, but Theano, for example, they've decided they will not make any more updates to their framework. So if you want to use it, you can use it, but there won't be any more updates. So virtually, I think Theano is going to be dying. But there are other frameworks in between. And if you haven't, I will only talk about only a few of these of the frameworks. And there are some frameworks which I have not talked about. For example, AutoML is a machine learning framework which actually develops machine learning models for you based on the data set you have. But I have not done any study on that, so I can't talk about them. There's some statistics about some frameworks available. If you look into this is around 2016, it's almost like a century ago information about the performance of the frameworks, and there seems to be huge support for TensorFlow in this case. If you look into over a period of a few months, especially on the developer following. Developer following is a good indicator of how good the framework is today and how good the framework is going to be going forward, because I think it's like having the critical numbers of people following certain thing, and then hopefully it's going to be growing on its own. But these are some factors I felt which are important for organizations to go for certain framework. And when I say organizations, I'm talking about mid-size, small-size, big-size companies, startups, and otherwise too. I was actually talking on the 17th, 2 days ago, on a different topic about how organizations can adopt AI. One of the big concern is about which framework to pick, and then I mentioned people at that time, they can even talk about this. Some factors for organizations are the following mentioned there: machine learning versus deep learning. I mentioned that as a top one. Why? Again, the recency of the topic of machine learning and deep learning is so that you just can't ignore the machine learning part of it, or the absence of deep learning. But deep learning is becoming so extremely important in the sense that I think the models are really performing well. In the image processing and text processing area, deep learnings have really shown spectacular results. To the extent, I don't have a slide today, but I think I have a slide about how in image processing, some of the models are actually performing better than human beings. The accepted human error in image processing is approximately a 6% top 5 error, sorry, and models actually have only 3 to 4% top 5 error. In other words, for every 100 images, models only make mistake on 3 or 4 times, whereas human beings make mistakes in 5 to 6 image situations. So it's better than model human beings. And similarly, I think in image processing, text processing, I think people have really done fantastic thing. Here is a spectacular area where a new research is happening, and I'm sure deep learning is going to really make a lot of impact. I don't know, how do I say this? I'm sure you might have heard of this because a lot of you guys are more intelligent than I am, but I think it's very latest. Image processing is being done, especially if using deep networks, to process image and make sense out of it. You might have already heard about this. In a healthcare situation, you can actually watch the patients, or in a security situation, you can actually watch people, or in a image content management situation, you can identify content not suitable for the policies and delete those content, all that stuff. But the privacy concerns in the image processing is making some companies to relook at, is there any other way of predicting, let's say, detecting human behavior or human activities in a room, let's say an indoor situation, other than video facility, sorry. Let me repeat that. If you have a use case where you want to find, let's say, a face match or user prediction, other than video facility, how would you do it? Other than taking pictures of people, how would you track what the human beings are doing in indoors? Have you heard of research happening? Yeah.
I think there's, I've seen something to do with heat, right? Like heat mapping, perhaps, or sounds. I've heard the latest, like there was something on NPR where they're listening to sounds and then very muffled sounds and then trying to reconstruct the conversation, exactly what's being said. It's being used for spying and things like that.
I haven't heard of that particular one, but predicting, or rather extrapolating based on, let's say, heat, humidity, or sounds, etc. I think I've heard of in another context too, not necessarily machine learning or deep learning. But to avoid this privacy concern, some companies are actually focusing on wireless signals. I'm actually working with a company in the Bay Area where they're using off-the-shelf network routers and using the signals the router is emitting and to predict human behavior, even as simple as breathing, sitting, falling, walking, opening the door, moving an object in the room. Especially this, of course, works in indoors, using signal processing, and especially within the signal processing, there's something called channel state information about various channels, the signals being emitted by various channels, and getting that information and doing a deep network processing on identifying human activity. One of the biggest problem which deep networks have not figured out, and that's the reason why I'm talking about deep learning versus machine learning, in this use case, people have not figured out how to avoid the impact of external things like humidity, heat, and other situations on the signals itself, and thereby the model performance is getting affected, which is not the case for a regular video image processing, because you have The image is right there in front of you, and then you process it. Other than those extraneous, how to develop a model to take care of these extraneous situations, but deep learning is becoming a lot more important for organizations, or text processing and image processing, and models are becoming really accurate. Another reason why I would emphasize that being the first factor is if you have heard of something called capsule networks being announced, I think just a couple of months ago, 4 months ago, by Jeff Hinton. It is taking deep learning to a next layer where image processing is going to be, I think, a lot more efficient, a lot more accurate, to the extent, I'll give you a contrasting story. If you know about image processing, let's say a facial recognition image processing model. You give 1,000 pictures of a human being, another 1,000 pictures of, let's say, a cat. It will predict, when you next time you show a picture of a human being, it predicts, yeah, it's a human being, it's not a cat, yeah? So typically you show a picture of a human being, let's say, with the nose and 2 eyes and ears and a mouth and stuff, right? You can experiment this yourself. Next time, when you have such a model, especially a facial recognition model, take an image, move using editing software, move the eye down and the mouth up in the same picture, ears somewhere here. So one eye is here, mouth is sitting up and down, and then the nose is somewhere here. Just the same face. And it will predict that is the same face what it has just now seen. Even though it's not a face, it's a deformed picture of a face. The point is, the current deep learning image processing models does not know the so-called something called hierarchy of the parts, the gate or position. There's multiple words being used, but the hierarchy of the components of an image is not being really addressed. So even if you have, if the image has the same components but they're deformed, model will still think, yeah, I find 2 eyes, 2 ears, 1 mouth, 1 nose, okay, that's a human being. And that's also, that if more research is being done on capsule networks figures out that easily, because it actually have a hierarchy. And because of that too, I think machine learning versus deep learning will be an important factor for you to consider which framework to adopt. But again, by the end of this 1 hour session, whatever deficiencies I'm going to identify in a specific framework, they may not be deficiencies anymore in 6 months from now, because I think all models are constantly evolving. But as of today, if you want to pick, that's what it is. CPU, GPU, I know some of the frameworks work both on CPUs and GPUs. More than whether they work on GPUs and CPUs or not, how easy it is for you to actually run a model which has been developed on a CPU to migrate it to a CPU, and especially if you can do a parallel processing or not. There are 2 types of parallel processing available at this point of time for machine learning. You actually can do a data parallelizing, and you also have a model parallelizing too. But parallel training of a model is a little more complicated than data parallelizing data part. But those are some of the factors you want to consider when you think about the frameworks. If you have a set of data sets already available versus if you have data streams coming in, that will itself impact your framework, what you want to pick. Spark MLlib, I think, is really fantastically suitable for if you have a stream of data coming in, because the MLlib really is integrated. Even MXNet and the other one from Amazon, is really integrated with the existing ecosystem and can actually work well for the models if you have a data stream coming in. But if you have a relatively non-changing data set, where you have the data coming in on a daily basis, but not every minute or every second, if you have, then I think you can think about other frameworks too. So that's another factor, whether you actually have data pipelines coming in. Cost of ownership, I think, yeah, some are available for free, but some you may have to pay a little more money to maintain them. For example, again, hope no one is recording it. Google, even though TensorFlow is really fantastic framework, the documentation really sucks. It's just, I think, you can't do a self-learning. I'm sure unless you go for a training, you may be able to learn. They are trying to, of course, work on the documentation now for 1.4, I think you already have, version 1.4, TensorFlow. I know TensorFlow from 0.8 version, 9, 10, 11, 12, then 1.0, 1.1. Documentation was atrociously bad. And so sometimes the implementation of some of these models was fantastic. A lot of APIs were available, but they picked up those APIs or implementation details from a specific paper. So they talk about the paper. Okay, this is the implementation based on paper ABC. But then you have to want to read the paper to understand how the implementation is done, or what's the objective, or what's the benefit of this implementation versus another implementation. So documentation is another important factor too. Tutorials, I think if you have, can you learn that yourself or can you teach your organization easily is another factor I would consider. And a bunch of other things too. And the most important factor of late is people availability. Someone told me around 6 months ago there are only 5,000 expert machine learning people available in the world, and 90% of them are working for 6 to 7 companies. That's it. And maybe I think in the last 6 months there may be maybe another 10,000 added, but there's a huge gap between the demand and supply. And I was mentioning, I think the other day too, on top of this demand-supply problem, some of the universities where the high-profile professors are quitting the academic jobs and actually joining companies, thereby affecting the supply again. On the left hand, I talked about the organization factors, but I think if you look into on the right side, if you individuals, you want to learn, if you are beginners, you want to look for frameworks. There's lots of tutorials, really good documentation, and of course, lots of examples. I think it's really a must. And if you're a decently trained intermediate people and you want to learn more, you need to find out community help, because especially if you get stuck in the middle, you should be having a Quora.com or Overstock, some of those question answers places you can go ask a question and you can get a quick response. And if you're really experts, I think the most important factor is pre-trained models available. The pre-trained model as a concept is popular for image processing. It's not yet for text processing. There are some models available, but they're not as many. Some of the examples I think posted in GitHub for, let's say, a question answering model or a machine translation model available for use may not work as efficiently sometimes, number one. Number two, they might have been written for a framework with an older version, and you've got to do a lot of changes, and in the process, I think you may be spending more time. It's not really available. In image processing, I think it's a little more mature, and you'll find more so-called model zoo available for image processing. With that, I'll talk about a few frameworks, and then let me tell you my personal bias before I even start talking about the frameworks. I have worked most of my time, good amount of my time in TensorFlow. I've worked on a little bit of Torch. I've experimented with Caffe, actually Caffe 2. Of course, I've used on Scikit-learn a long time ago for a different purpose. Which are the other ones I worked on? I have Keras, of course. I worked on Keras. I've studied the working of MXNet, Spark MLlib, and I've started reading about Paddle. Not much of information available there for me. CNTK 2.0 just came, I think, 6 months ago, something like that. DMTK I've not used. So I have used Theano too. I've used Theano, but no more. So TensorFlow, Caffe 2, Torch, a little bit of PyTorch. I've used Scikit-learn. The other ones are based on my understanding of what I've read online, on the documentation of the framework, and based on my discussions with people. So yeah, I'm not an expert on all of these frameworks. The most commonly heard of the name of the framework is, of course, TensorFlow. It's really evolved. The first version, non-draft version, was available, I think, in Feb of 2017, less than a year ago. Till then, it was changing so frequently. If I tell you, give me a second. I know you're taking pictures, but give me a second. TensorFlow, when you download TensorFlow today, you will get 3 variations of TensorFlow with that, all created by Google, and you would not even know that there are 3 different frameworks coming with it. It's called TF Slim, TF Contrib.learn, and I think TF Learn. Yeah, TF Learn, TF Slim, TF Contrib.learn, and of course regular TensorFlow. All from 4 frameworks automatically installed when you download it, and all made by Google. Keras, which actually has a front end for TensorFlow, is done by a third party. I think PrettyTensor is done by a third party. Sonnet is another wrapper on top of TensorFlow done by DeepMind. So there is a funny discussion about framework TensorFlow versus Google. Maybe Google themselves in the company itself, they don't agree on which framework they should work with. So they actually have so many frameworks internally. And I think my suspicion is the development on all of these frameworks is happening simultaneously. So you would see tfcontrib.learn, you would see updates happening to those files. You have regular TensorFlow modifications happening all the time. TF layers is also, I think, contributions happening, and there are people available who are actually making contributions to those. But that's a funny part of it. Sonnet is actually is a wrapper on top of TensorFlow. It really integrates well with TensorFlow, and you can use that. Anyway, that's about TensorFlow unique situation.
For a beginner like me, what would you recommend to learn? Whether
You have to wait for the last slide. Sorry, yeah. I could not resist the temptation, but yes. Again, there is no single answer for this. As I mentioned to you, there's so many frameworks available. Every company is putting so much of investment in developing the right framework. One is ahead of time than the other frameworks. But I've seen, for example, PyTorch, which just came 8 months ago, I'm guessing. It is so well being used in the research areas, all the academic circles, and if you really want to do fundamental research on machine learning models, PyTorch is the best one because it's very it's relatively stable than Torch. Torch is the older one, and it's really stable, but PyTorch is becoming stable, and it's written in, you have a Python wrapper around it, people actually can use it. It does allow you to do your custom development of, let's say, your activation functions or optimizers and all of that stuff it allows. Also, it has its own APIs, but that's only came 8 months ago. So maybe some model called, I don't know, skready.com model comes up. Maybe it may become better too going forward. I don't know. But I'll let you know towards the end of it. Yeah.
So I talked to the author of the TensorFlow Lite at ARMCon a couple of months ago, and it seems like he's pushing vaporware, because I asked him when he's going to release it, and he wouldn't give me a date. And I said, is it 5 years? Is it 10 years? Or is it 5 months? So he said somewhere between 5 and 10 years. So I wouldn't be listing that. He pushes it as if it's ready, but when you poke him on it, he says it's not ready.
Okay. Yeah, I don't know that information.
Yeah.
5 years, 10 years, it's actually a lifetime. I won't even talk about if something is coming in 5 years from now.
TensorFlow Lite.
I don't.
TensorFlow Lite. He's kind of selling it like vaporware. There's nothing actually there, and he says it's not going to be ready for 5 to 10 years, so he shouldn't even be talking about it.
Yeah.
But he's acting like he should be using it today.
Yeah. Okay, so let's talk about TensorFlow itself, some of the features, and again, these are not in any order of increasing importance or decreasing importance. It's really portable. You have lots of neural network models available. Any type of model you can think of in textbooks, in technical papers being published, in any blog mentioned, in any conference people are talking about it, they're available there. Even to the extent, if you're looking for open source code for some of the production level products of Google in machine learning are available in GitHub. If you want to run the Google neural machine translation model that is actually on the productionware, if you want to do a Google translation on google.com, the code that's being used to run that is already available in, including the datasets are available in GitHub. You can run it. So all the APIs, all the models you can think of, whatever you can think of is implemented for all statistical machine learning, NLP, image processing. I think there are for audio processing too. There's lots of models available for audio processing. There's a good GPU support. You can just with just a flip of one single line, you can actually tell the model to actually run it on a CPU or a GPU. But again, I don't know how many of you guys have used GPUs. One of the problems with GPUs, and I say problem, it's not actually, it should be easier to it becomes better and faster if you use a GPU, but there's a lot of memory management programming you've got to take care of when you're actually running which you developed a code using a CPU, but you're running it in GPU, you've got to make sure the memory is managed well. There's a fantastic support of Python, and you can also have other wrappers too, but I think it's written in Python. Documentation, I was not sure. You see my multiple question marks there. A year and a half ago, I think when 0.8 version of TensorFlow, which was I started working on 2016, March, April, May, sometime June. At that time, documentation was really, really bad. I know they worked. I even spoke to a couple of guys developing in Google. I was asking him, how do you get trained when you want to train your employees? He said we have a different version of TensorFlow in the company versus what we open source outside. So I think that particular version of TensorFlow, what they had internally, had a better documentation, plus they had training material too. But for public, I think it was a difficult issue. One of the best things of TensorFlow, you had a question?
One question, like, if you wanted to find out, like, the existence of pre-trained models, that work with TensorFlow, like, just simple Google search is the best way, or is there some sort of a catalog somewhere? Like, is it, for example, audio to text transcription, right? I mean, is there something there that you feed in an audio file gives you the text of those kinds of things? How would you go about finding it out?
Okay, you asked multiple questions in that. One is, if you want just an API, which is where I just give my text and I want a speech out or speech to text out, those APIs are already available at google.com. You can just get the thing going, and you can, if you're a small company, you can start using that API, and you can pay a little bit of fees and stuff too. But let's say you want to develop a machine learning model for, let's say, TTS, text to speech, and the other way around, or image processing and stuff. They are available on, you can give a Google search and find out, but eventually going to lead to a TensorFlow repository, and then it'll give you. Many times for you to use a pre-trained model, because you can use pre-trained models for two purposes. One purpose is, you take the model as is, maybe you can, you don't even care for any more training. You install it on your company servers and start using it for making detections or whatever it is, let's say image processing model. The second purpose of pre-trained models is you take a pre-trained model, let's say there is an image processing model available which has been trained on all animals in the world. But you want to train that on human beings because you are, let's say you're a hospital, you want to train on your patients, or let's say you are a university, you want to train on your students. I don't know how many of you guys are image processing experts. Like if you have a multi-layer image processing model, the earlier layers, the initial layers, are experts in figuring out the corners, the edges, the colors, the combination of a few edges and stuff. Like for example, some layer out of the 50 layers or 100 layers, there will be one layer which is an expert on figuring out an ear, just a ear, a right ear, a left ear. And it knows, okay, that ear seems to belong to a human being and not a cat or a dog. And let's say you have such a model available, you can take the pre-trained model on all cats and dogs and animals, and you freeze the entire set of layers, and the last couple of layers you can take out. Typically, the last layers are called fully connected layers, FC layers. Take them out and put your new FC layers and retrain the model where the rest of the layers don't get updated, the weights in the rest of the layers don't get updated, only those two last layers gets updated. But the model is already intelligent enough to figure out the colors and the edges on the corners and various body parts, but it's now saying, okay, fine. Oh, that ear, there has to be ear, but the ear has to be slightly different for a human being, and hence the ear is going to be this. And that learning is faster, and that's the second purpose where you have take a pre-trained model. Cafe 2 is the best framework to actually have pre-trained model, and even in PyTorch too. In PyTorch, it's even more simple. You just invoke the model in the arguments. You just say pre-trained model is equal to true. It does a fantastic heavy lifting in the background. Just that one sentence. It checks whether you already have the pre-trained model. It doesn't, goes downloads the latest version, installs it, and tells you where it is. And figures out where the data set is, and when you said next, maybe if it's a Kara statement, you say fit the model, it actually takes the pre-trained model, takes the data wherever you mentioned it, and start training. So that's the advantage of a PyTorch, and even same as the case with Cafe 2, I think it's very easy. But if you are into developing new image processing models, using pre-trained models, Cafe 2 would be a fantastic framework. Okay, the best feature, especially for beginners who want to learn what's happening, and if you have a little more research bent of mind, if you want to do that, TensorFlow is really has a good feature called Tensor Board. It's actually a visualization tool. It actually tells you graphically on how the code is being executed, how the model is training, whether it's overfitting or generalized enough, or you can see how the accuracy numbers are changing. So it's a real good visualization model. It also visualizes the graph, how the graph is working when you're executing it. There's no other frameworks that has a similar feature except PyTorch has something called Wisdom with a V, V-I-S-D-O-M, I think Wisdom, which also is a visualization tool. But one thing I know for sure they don't have is it doesn't show the visualization of how the graph is working when you're executing. If you are into developing a production-ready model, you may want to find out how the model is working when you're using visualization tool. So from that sense, I think TensorFlow has a unique capability. The Tensor Board is really a good one. Flexible architecture for CPUs and GPUs. You can actually have both CPUs and GPUs working on your model. And you can also have only a certain portion of the training happening on CPU, certain portions happening in GPU. Even if it's on the cloud or it's on the server, etc., I think that it's quite easy to do. There are tutorials available now, I think in the last 3 or 4 months, maybe 6 months available on how to use TensorFlow. Also, if you give a YouTube search, there are a lot of conferences people have spoken about how the introduction to TensorFlow. I think even there was a session yesterday or day before here in this conference. So it's getting more and more easier to actually learn TensorFlow. Yes, yeah. Of course, it's being used. TensorFlow is being used for a bunch of applications, but I think, in my opinion, and it also works with lots of operating systems. I have not found yet a framework which has more implementation of various techniques and models in machine learning compared to framework. That's on the positive side. On the negative side, the implementation is slightly more cumbersome than, let's say, the easiest framework to learn is Keras, for example. So compared to Keras, it's a little more cumbersome. You got to write a lot more lines of code, and you got to actually you got to take care of so many things yourself while you're writing a TensorFlow program. Yeah, that's the.
But with the Sonnet wrapper, that should be.
Oh, yeah. Sonnet, Keras, many of these wrappers, it's extremely easy. Yeah, but the problem, of a wrapper. Okay, maybe I'm jumping ahead of myself. When you have a wrapper, it makes it easy for you to write a program and run a model. Yes. But if you really want to make it efficient, the difference between a 91% to 92% accuracy, there's a tremendous of effort that goes into that, because I want to talk about a speech I gave in a conference, H2O World Conference, just happened a month ago, I think. When you have an image processing model that, let's say, runs on a CPU or a GPU, and if you're trying to make it on a mobile device, which actually has less computing power, there's so many factors you bring in and techniques you bring in. Let's say there is something called a concept called pruning. In image processing, there's a kernel which is actually going over on each image, and it's actually doing a lot of mathematical computations. The size of the kernel is an issue which has a direct impact on the time it takes for computing. But if you reduce the size of your image and also reduce the size of your kernel, the computation will go down, but also does the efficiency, the accuracy. The accuracy versus computation time comparison, balancing is a big issue of late. For example, have you guys heard of YOLO? In image processing situations where you only look once, it's a YOLO 1, YOLO 2. They have actually developed a real nice image processing model which is extremely fast. But they also have certain, I think, earlier versions of YOLO and certain versions of models called faster RCNN. They sacrifice a little bit of accuracy for the sake of speed. especially if you are doing an autonomous cars and if you want to have the machine figuring out what's happening, what object is on the street and decide whether to still go ahead or not. You want the model to predict even with 80% accuracy or 85% accuracy, 90% accuracy, but in a very, very short time, let's say 20 milliseconds or 30 milliseconds, not 1 or 2 seconds, because if it takes even 1 to 2 seconds, car driving at the speed of 60 miles per hour, I think you'll be actually covering so much more distance, it's going to be dangerous. So once you get a wrapper, it's easy to program, but if you want to really customize it to make sure it's most efficient, I would actually go 1 or 2 levels down. So in this case, it could be a TensorFlow, or if you're using a PyTorch, I think it would be a PyTorch. Caffe is an entirely different model. I'll talk about Caffe 2 especially. So that's the balance between a wrapper, to use wrapper or not to use. If you're a beginner, if you are trying to understand how the model works, what machine learning is, if you want to experiment a few things yourself as a beginner, or even intermediate, Keras or Sonnet, any other wrappers would be really good. Caffe 2. Facebook actually is supported a lot in Caffe 2, and by the way, PyTorch is also Facebook's contribution. And that's another interesting factor. Google actually has thrown in their weight behind TensorFlow, and they want you to use TensorFlow for all the purposes. Any activities you have, whether it's audio processing, signal processing, text, image processing, for your classroom environment or a industry environment, they want you to use TensorFlow, whereas Facebook wants you to use PyTorch if you're developing models, more of research type of models, or developing really strong performing models. But if you want to use a model for production where you can quickly develop something and really works efficiently, using sometimes the pre-trained models, they want you to use Caffe 2. So Facebook has 2 frameworks, Caffe 2 and PyTorch. And Caffe 2 is even more efficient in terms of flagging between GPU and CPU. It's just one single line of code you can write. Caffe 2 actually is very popular for image processing. I have seen 90% of the papers I have read in image processing using Caffe as a framework and using the model zoo. There is a concept called model zoo. Lots of models, image processing models, pre-trained models are available in Caffe, and it's very easy also to use. And the second best thing about Caffe 2 is you actually don't write. Many times you don't write any code. Can you imagine that? You don't write any code. What you write is some sort of a JSON-like file. It's called proto.txt. It's a bunch of lines of code which is doing nothing else but telling the model, or telling Caffe to say, okay, go look for data here and pick up the data in this sequence, use this model and train it. The proto.txt is it's almost like a text file. It could run as small as maybe just 100 lines or 200 lines. But on the other extreme, it could even run 7,000 lines. For example, the 152 layer ResNet network proposed by Microsoft in 2015 was developed in Caffe and is running on Caffe. It had 7,000 lines of proto.txt lines in it, which is actually too much for a human being to write so many JSON-like lines. You should actually Google and find out how a proto.txt file looks like. So you literally don't write too much of code there. That's so if you're doing some image processing, if you want to use some pre-existing models, pre-trained models, Caffe would be a good area to start working on. So other than computer vision tasks, I have not seen too many people using Caffe 2. Yes.
About the Caffe 2, is there regular development for the platform?
The recommendation is if you're developing a model for your case, let's say you're a hospital or a healthcare company, or if you're a retail company trying to take images of people, what they're putting in the baskets, and then analyze what's in the basket and make some recommendations, if that type of. For developing a fundamentally new type of model, use PyTorch. But for you to run a model on production, or if you want to use a model, a pre-existing model from the model zoo and train a model and then use it for production purposes, run it on Caffe 2. That's a recommendation. So if you're developing, or if you want to play around with image processing models, use TensorFlow or PyTorch. Or if you want to even develop a model, use PyTorch or TensorFlow, not Caffe2. I would recommend. I've been recommending Caffe2 for companies where actually if they want to have a production-ready model being run, they would actually do that. Also, for some reason, I think Caffe has become really popular for image processing, not as much. So I think you'll find a lot more APIs available for image processing in that.
So question, what advantage does Google get by asking everybody to run TensorFlow? It's publicly available, right?
Okay, it's a generic answer compared to why would they give the Gmail for free and all of that stuff too. One is the brand. You're using something, a Google product, so you eventually do a lot more Google stuff, number one. Number two, it'll also establish them as the leader in a machine learning, so that's why I think they want to open source it, and there's a lot more money by giving away things for free, the illogical logic that came out a few years ago. Give out for free, you'll get more money thing, that's the same logic there. Third is, today, because I'm into machine learning for so many months now, and then I've been reading so many stuff, what's happening there, I would know personally, but I think for a non-ML person, even non-ML person automatically know Google actually is really, really on the forefront of machine learning. And one of the ways of doing that is if you look into the papers and if you look at the TensorFlow itself. Of course, the people they're hiring and of course the contributions they're making, and even if you go to, there was a survey done by Kaggle recently about the best framework. I think majority of people are suggesting to use TensorFlow. So I don't know what started what, but the number of users, developers, contributors, the size of the community, number of solutions available, tutorials available, the stability of the model, the brand name of Google. There's so many factors which is compelling a lot of people actually to start going for it. So it's like a tipping point. Once you cross certain critical mass, it becomes, it runs on its own, and that's what is happening with TensorFlow.
Also, I heard that they want to rent VMs where you can run their TensorFlow on their cloud and charge you money for it. That's where they're eventually going with all their TensorFlow chips. It's going to be a service that you get to run your machine learning on.
And I think in the bigger war, they can influence the decision. So if they have a larger developer base on TensorFlow as compared to what Amazon or Microsoft is doing, that they drive the future.
Sure, it makes sense, business sense. I'm sure we're not criticizing Google. There's no one for Google, right? Anyway, yeah, absolutely. Yeah, so many reasons why. But again, as I said, it's the same reason why Google is giving Gmail for free and so many other things for free. It's just part of the brand, the way they're managing brand. You had a question too? Okay, so we have another 15 minutes to go, and I'll see if I can come to her slide, I think, as soon as possible. PyTorch. PyTorch just came 6 to 8 months ago. The predecessor for this was Torch. It was one of the biggest problem in Torch was a new language called Lua. You were forced to learn a language Lua, but PyTorch, that's not the case. It has been written and it has a nice Python wrapper, so you can actually do everything in Python. It still has the same C background, C++ backend, and you don't need to use Lua anymore. It's stable enough because it's the original mass of the structure is Torch. But because the new Python wrapper, I think there's a few issues compared to Torch. So PyTorch is getting stable. And it also has, as I mentioned to you earlier, using a pre-trained image processing model is a lot more easier in PyTorch too, as simple as just setting a flag. You just have to say pre-trained model is equal to true, and then that's it, it picks up whatever model you mentioned. PyTorch is very close to regular Python code. Also, one simple difference, I don't know why it's a major difference, but I think PyTorch says it's a major difference. When you run TensorFlow, you still have to download or invoke pandas, NumPy, sorry. You have to still use NumPy, but when you use PyTorch, you don't actually explicitly call PyTorch. So I don't know what the benefit of that, just because it's already integrated well in PyTorch, maybe that's what it is. But you don't call NumPy anymore when you're doing PyTorch, but you do that when you do TensorFlow. It's been actively used by Facebook because that's one of the sponsors. I know there's some projects in Google. Apparently, I don't know the names of the projects, but I'm told they're using it there too. The huge amount of research and development of code that will run on NVIDIA GPUs is going on. for multiple reasons, because of course NVIDIA itself is actually encouraging that, even though they have their own bunch of other frameworks like CUDA frameworks coming in, and they want the CUDA or CUDA DNN frameworks also becoming smarter and intelligent, but PyTorch really works very well with any of the GPUs of NVIDIA GPUs. So if you have GPUs and if you know a little bit of Python language, I think you should go for PyTorch.
Just a question. Why is it actively used in Google? Competitive reasons or study reasons? Or?
When I say actively, I'm saying Google is also using. Actively being used in Facebook. Facebook is the primary, because they are the ones who are actually sponsoring the whole model, PyTorch. Google is also using it, but why they're using, I don't know. Yeah, could be a competitive reasons. Yeah. Also, by the way, I can predict the reason, and the reason is PyTorch is really good, works really well for some of the research projects. If you look into even Stanford or even Harvard and Oxford papers when they publish, many times the open source code is in PyTorch because they worked in PyTorch. And if you actually talk to some of the people also, the PhDs, all of them like PyTorch, not TensorFlow. And maybe I think because Google has a research team, I think they're using PyTorch.
So what's significantly different? I mean, they use very different ML algorithms. Is that what?
No. They have the same ML algorithms if you're using, but the way you write a program is different. Actually,
yeah, but interface is different. But the thing is, if researchers are using a lot, they like it a lot. Isn't it because the ML algorithms?
No. The reason why researchers prefer that is because there's a lot more flexibility in defining your own. Let's say activation functions and optimizers. You can actually write your own. So if you're into research, let's say you think ReLU is not no more interesting for me, or TANH is not going to be interesting for me. I want to create my own activation function. They can actually do the research and see how it works. And that in the context of, let's say, overall assignment or experiment they're doing, they can work in that. So they actually can go a little more down level, I think. Yeah.
Easier in PyTorch.
Yes, easier in PyTorch. Yeah. That's why it's more of research-oriented framework. Spark MLlib, I think I already mentioned, if you are using some sort of a dynamic databases and you actually have streams of data coming in, and if you're already using Spark, you could use MLlib. You can use Python for this. You don't need to go just for Scala. But the problem is, I think they just came out with, I think at least I know 4 months ago when I read about MLlib, they don't have all the machine learning models implemented. At least they don't have too much of deep learning models implemented. So if you want to make an API call, you got to develop everything in Python, which is a ton off. But if you have your organization already uses some Spark variations of Spark in it, you might want to think about MLlib. They're actually really working hard on this, on developing the machine learning models on ML. So there's some of the other information too, but I would recommend MLlib, again, my personal opinion, only if your organization is already using Spark. Otherwise, it doesn't make too much sense because the maturity of the model is not high compared to, let's say, PyTorch or a TensorFlow or even MXNet. Yeah, you had a question?
So the open source TensorFlow is a single machine thing, right? It's not a distributed one.
Oh, that's okay. Good point.
Right, and with the Spark ML, what I heard in the Spark conference is you can specify at each machine level a TensorFlow, and then a Spark can talk to the TensorFlow by itself. Do you have any insights on that side? How can we, how the integration is, and how easily the frames can transform?
Yeah, it's a little bigger discussion we could actually have offline. What I can say is the distributed computing using TensorFlow, no one is using except Google themselves because they're trying to do research themselves on how to do the distributed.
That's a proprietary.
At least it's not open source. In the sense, if I want to use TensorFlow distributed because they're open sourcing everything, why not they open source that particular capability also? But they have not done it. Maybe because it's not stable, or maybe they have not figured it out, or maybe proprietary. They want to keep it the crown jewels for a while before they open source it. I don't know, whatever reason it is. But today, the open source TensorFlow does not have distributed computing. If you actually have multiple machines in multiple locations and trying to do small pieces of it, working on it, that part of distributed computing, I think, is not available in TensorFlow. But you can do, let's say the model being trained on multiple GPUs. Let's say you actually have the data parallelization. You actually have data being served to the same model in the same GPU, but different GPUs and different CPUs are serving the data to you. Or if you're having multiple GPUs working on See, the model parallelizing is difficult, whereas data parallelizing is easier in versus multiple GPUs or GPUs versus CPUs. But distributed computing, I've not heard of much yet.
So there's a presentation, I think yesterday or the day before, where the presenter said what he did is he took TensorFlow, underneath of it he did a test with distributed TensorFlow, and he found it doesn't scale, and instead he replaced it with all reduce. So all reduce is a distributed ring topology where all the GPUs send information in a circle, and each one works on its piece and gives the result to the next GPU, and then once it's all complete, you have your answer, and that's actually more scalable than distributed TensorFlow. And so that might be why Google is not using it, because it doesn't scale. And
Yeah,
so
you're right.
All reduced together with TensorFlow is the way to go.
Yeah. So that's one of the downsides. You're right. I think distributed computing, I think, is not yet into TensorFlow. Yeah. But again, I don't know. It's academically nice topic to discuss about, but I think only companies like Facebook and Google, I think, has the scale and the need to do the distributed computing. For small companies, let's say if you are a Kaiser, if you are a Target, if you are a Walmart, if you are a airlines, American Airlines, I think you don't need so much of distributed computing. I'm guessing, but again.
You'll do the whole file and everything in the one machine?
No, you can have multiple GPUs, but then as I said, you can actually have data parallelizing happening. You can actually make it faster. And in a few situations, you actually can have the model parallelizing happening, where you actually have half the model getting trained in this GPU and the half the model getting trained in this GPU, and eventually the weights can be merged, but that's a very complicated thing at this point of time. 2012, the first image processing solution using CNNs, and hence the accuracy dramatically improving, that happened in 2012. And the model name is called AlexNet. It's done by Alex something something, and the name of the model became AlexNet. That is the first instance, at least in the popular circles, where he tried to train a model on two different GPUs. So half the weights were in one and half the weights were in another GPU. They trained using so all the data is getting into both the GPUs, and they get trained, and eventually the model will be merged. The weights are getting merged. But I have not heard of 2013-14 winners of ICLRS competition for image processing, both for localization and object detection. I have not heard people using multiple GPUs, because at that time I think the GPU memory was only 2 GB. Now you already find, I think, 16, maybe even 32 GB also you can find a GPU memory, not the hard disk, but GPU memory. I don't know what the reason is, but I haven't heard of models later on where you actually have the model parallelizing happening. Data parallelizing is I've heard enough times.
So,
But again, that's again a big size company is trying to do it. But even as simple as, I don't know how much data Macy's has, but anyway, sorry, go ahead.
So last year there was this famous worldwide publicity event, right? The DeepMind to go alpha that beat all these
Beat the humans, yeah.
top players. So there they Hasebo, the DeepMind guy, so he was asked. So that version that beat the humans, that was a highly distributed model. They were using massive network for that. But the one that they have shown to others also to use and all that, that is a single processor.
Sure, yeah. So I think what you're saying is right. I think TensorFlow is not designed for distributed computing. People are doing it in Google, trying to do distributed computing, but it's at least as part of the open source code with a simple flag setting or maybe a little bit of a code change. I don't think they can actually do distributed computing. Some amount of distributed computing for data parallelization, that only just picking up the data from CPUs, machines, the hard disk to the CPU memory to the GPU memory and making it available to GPU model. Maybe that's happening a little more frequently, but I've not heard of the model getting parallelized. Okay, that's Microsoft came out with this new model, CNTK. I think CNTK2 also is another one. Earlier, it used to be called. There's an expansion for that. They changed the whole expansion. CNTK, DMTK. There are two different versions. DMTK is a deep learning machine learning model by Microsoft. CNTK is another machine learning one. don't have enough models, not really exciting at this point of time, but they are really fast focusing on integrating with the rest of the ecosystem of Amazon. So if you, with Microsoft ecosystem, if you are using Microsoft cloud and stuff, maybe I think these models will work. But whether you're a beginner or an intermediary or an expert, again, don't quote me outside, but I wouldn't recommend CNTK or DMTK. Apache MXNet is relatively new. I think it's supported by Amazon a lot, I guess. They're also trying to merge with the regular existing ecosystem. Runs on Python. Very similar to TensorFlow, but less of APIs deployed yet on this. So MXNet, CNTK, CNTK2, these are all relatively new entrants, and they don't have enough maturity yet in them to use. Scikit-learn is one of the earliest frameworks available. If you really want to experiment, especially in the machine learning part of it, the statistical machine learning, you can use it. It's very stable. You can use Python on that. But this is too beginner. If you really want to become a strong machine learning player, I think you can start with not Scikit-learn. Theano, I don't want to talk because I think they recently announced that they will not come out with any more updates. So for all practical purposes, Theano is dead. There are some frameworks, for example, if you're going to look into the GitHub star count, TensorFlow actually has lots of star counts. So looks like I think it's really popular among lots of people. There's some more statistics about this, some more here. There's a technical paper published about the speed of a model developed using some of these frameworks, and you can see the numbers. I think they are inclined towards. Well, I think it's more distributed. You actually have Torch actually performing in certain situations, and some situations I think TensorFlow performing. But this will be a good. You can look at the paper. I think I've shown at the end. You can go back and read that paper more to find out what their conclusions are. But there is no single hands-down winner of framework, according to these people, based on, of course, the hardware they have used, on the data set they have used, and the model they have used. Okay, this is my
question.
Yeah.
Before you go to the, if you are big into AWS ecosystem, what are your thoughts on AWS SageMaker?
They are supporting AWS. I think Amazon is working on this one now. And MaxNet, I think they recently started supporting. And there's one more, I think they mentioned.
But they released SageMaker, right, which makes it easy for.
No idea about that. No. Yeah, I've heard of the name, but
November they released it.
Yeah, I'm not done.
They help to build and deploy much more easily in their ecosystem and stuff. So.
Google has not done that yet, but Microsoft, Amazon are the two big machine learning framework developers who are also trying to. The differentiating factor they want to bring is how easy it is to integrate with their ecosystem they have. Yeah, that's the differentiating factor. But I think it depends upon what you have. If your requirements are, okay, I want to have good stable framework with lots of API calls, implemented lots of models, and maybe it's easy for me to set the parameters, etc. Then that would make you tend towards certain frameworks. But if you say, oh, I already have this ecosystem, but I want to see what framework I can fit into this ecosystem easily, even if the framework is not really mature, I know it's maturing eventually, that would make you go towards a different set of frameworks. Yeah. You know, I spoke on their conference twice already, and I also, there's another meetup coming up. I'm going to speak on that meetup. So how do I say it politely? It's I think part of it is open sourced, their framework. They also give a lot of good support. For a small size, mid-size organizations, if you don't have internal capability of developing a solution, but you want good documentation and good training to be done for your employees and help you also with developing a solution, H2O I think is a good framework to start working on. I have not done development in H2O myself, so I would not know too much of information there. God, I'm recording all of this stuff, and I know I'm going to put it on YouTube. I don't know what I'm going to say, but if you are depending on your requirements. If you are an individual and trying to learn, I would recommend in my next slide, I think different frameworks.
Because they have distributed
Yeah. So I'm not sure. I don't have too much information. If you have any comments.
I've done some work on H2O. So we develop mostly in Java, so it's like very friendly for that. It's all written in Java underneath, so that was very useful. I think they do a good job of implementing certain algorithms. They're like kind of first to implement. So we have some tie-ups with some Stanford professors and others. So if you're looking for the latest and greatest algorithms and the most efficient way to implement it, they're very good for that. I was quite intrigued by the news they had, this whole self-driverless AI type of thing that they have, where basically, they're taking away the data scientist piece of it. So you basically give it the data, and then they have this algorithm that figures out AutoML, so it sort of figures out what's the best model and including all the hyperparameters and everything. And obviously, it sucks up lots of compute
like
power.
close to 10 different algorithms with different parameters they write out
So
and
that's,
tell you.
Yeah.
So they're going in a certain direction. It's kind of hard to tell, but
Yeah.
our experience generally has been they've been very fast. They're very fast libraries to use and
Sure.
very Java friendly.
Okay, thank you. Yeah. See, AutoML is a new direction. I think many companies are trying to develop. So that'll make all of our jobs go away, because I think then you don't need a machine learning expert, because the model is going to develop another model. But I don't know. I think it's an unproven technology yet. I think.
Somebody has to write that one, right?
Sorry, somebody has to.
That's right.
Yeah, but I think by a fewer number of people, I think you don't need too many people to write it. So yeah. So for example, Macy's can just go for AutoML, or maybe I think all of you guys can just go to Google or wherever, I think, then do an AutoML stuff. But anyway, and it's the same thing. Like, when ATM machines were introduced, I think 30, 40 years ago.
It's just good for the beginners to get some make sense out of it. After that, if you want to improve the performances, or whether this use case is really viable to take it productionalized, then you really need to go after individual algorithms and do hyperparameter tunings. But just to start with, whether your use case is having a potential or not, it will be a good starting point.
H2O, you're saying? Are you saying H2O is a good starting point?
No, AutoML I'm saying. For that case.
ML is so recent, I don't think I actually have an opinion either way. But the whole direction is where, instead of you doing hyperparameter setting, and I have a model which actually does so many settings and then does the computing for you and then shows you a bunch of accuracy rates, and then you can actually go for a single model or an ensemble of it. This entire line of thinking is so recent. Maybe H2O is doing a little bit of that. I know AutoML is doing that. There are a couple of even other companies too. I think Uber came out of some model called Michelangelo, and I don't know. I think that's also going towards AutoML type of approach. I know a bunch of startup companies in San Francisco. I even meet them often. They're developing almost AutoML thing but they're looking for a very small, a narrow bandwidth of, let's say, if you're looking for, let's say, healthcare solutions, but with maybe only 1,000 patients, but looking for only NLP type of solutions, we actually have an AutoML which actually will develop a model for you based on the data. So you give me the data, the model will look at the data and develop a model for you without actually a human intervention. But the whole approach, I'm not sure. I'm not an expert yet on that. I don't think. Yeah, I'm not an expert on commenting on AutoML type of thing. So from that sense, the problem, anyway, I'll say this anyway. The problem with H2O, if you want to learn H2O, is today, let's say, as an individual, for your own self-learning, or for if you want to good job prospects going forward, or if you're a company trying to experiment with that. But the moment you've reached the limitations of H2O, then you are stuck. You got to relearn everything else, maybe faster, on entirely different frameworks. So many people, individuals or companies, they're going for frameworks which has a long history in the back and projected future stability and the maturity and the community and availability of people. These are some of the factors. So if you have a small size company, that's where if you don't have the tipping point is a problem. These companies have not reached the tipping point, and hence I think it's very difficult to predict or grow. So I want to get to this slide, my prediction slide. I don't know if you were there on first day. The problem with predictions is there's a professor by name Professor Philip Tetlock did a research of 20 years, interviewed 284 experts, tracked 28,000 predictions, and he felt that the more expert you are, your predictions, the more wrong your predictions are. But having said that, these are my predictions. I would say if you don't have any other unique requirements, you should go with TensorFlow. If you want to use any wrapper on top, like a Keras or a Sonnet, Keras actually is a lot more popular and it's a lot more easier to develop using TensorFlow as a backend. It also used to work with Theano, but Theano is going to die now. Keras would be a nice one if you really want to do experimental projects, if you're trying to do your ML, MS or PhD, or if you want to develop a real intelligent ground-up model, you can start using PyTorch. But right now, for image processing models, Caffe2 will be the best model, and for all other purposes, I think TensorFlow. But Google says, even for image processing, we are really fantastic framework, but right now, at least, Caffe takes the lead. The reason being, Caffe actually has Model Zoo. And for mobile devices too, if you want to have your image processing models, especially for mobile devices, TensorFlow and Caffe2 are really good to use. And as I mentioned to you earlier, use MLlib of Spark if you're already been using Spark for any of the purposes. That's my last slide. I'm 6 minutes over.
Are you going to share this slide?
Yeah, this set I will share. I'll ask the organizers to share it with you guys.
Or at least can you show the last one?
No, you don't want my name? Okay, you want this one.
This is good for you.
I know you're using
Okay, if you don't have any questions, gentlemen, I think I have another session going on now. For people who just came only for frameworks, you're welcome to leave. I'm actually going to